In this session, we try to elaborate on biochar in Europe from an industry perspective. Industry, that is system providers, producers, refiners of biochar, and traders of biochar and biochar-based products. I'll try to speak about their needs, their capacities, and some restrictions they might face. This is basically our raison d'être, so the right to exist for EBI, as we're trying to facilitate a prosperous development and growth of biochar in Europe and the European countries. So in this presentation, I'll present the situation and briefly the work of EBI. This is the structure. I'll talk a bit about the market and its growth, the market barriers that we're facing. They're very closely tied to regulations also. I'll talk about industry standards, certification, then about communication, because communication is key. I'll talk about the knowledge about biochar. Well, that is still quite limited. I'm sometimes surprised of how little people know about biochar, even of its mere existence, even though I'm talking to otherwise quite well-informed people. On the other hand, there are some very positive recent developments where people are asking us, also large industrial players, looking for ways to improve their carbon footprint and to substitute fossil-based materials. So it's a lot of development, but still we have a bit of work in front of us with regards to communication. And then I'll talk about EBI's work a little alongside this presentation, and then in the end a bit more. So that's highly interesting to many people asking us or writing us. EBI has conducted a comprehensive market review on biochar production in Europe, and this has been some important work that we're about to finish it. And by the end of 2020, we had a dedicated production capacity of almost exactly 20,000 tons. The actual production was a little lower than that. It was 16% less, and this is due to that the number above the 20,000 tons, they include equipment that was commissioned throughout the year, but was not yet productive for this year. So we're starting with a capacity of 20,000 tons into this year. The market is growing exponentially. The production capacity doubled in only 2 years, from 10,000 to 20,000 tons from the end of 2018 to now, to the end of 2020. And the growth rates are shown here. They're also increasing, actually. We have a 5-year growth rate of 39% and a 3-year of even 44%. So for 2021, things will get really interesting, as we're expecting a higher growth rate of 75%. And EBI will publish summarized data in February that will be accessible, but a more detailed real market report with a lot of insight will be available for our members. So now to the reality in the field of for biochar producers and system providers. If we're talking about the setup of a plant, the regulations and certifications are really highly important. So we're talking about input material, about classes of input material, different feedstocks and their qualities. We're talking about the pyrolysis plant itself, about the system, and about the process management. And then again, in a last step, which they all have to do with each other, about the end products. So there are different regulations for all of those. From the production side, we start with the system providers. I've shown 3 exemplary systems. that are highly sophisticated. On the left, you see a Synkraft plant, one of the larger ones. And when Mattia was talking, I was thinking about this because you're talking about high temperature biochars. This is a pyrolysis and gasification process with over 900 degrees in the end. So I think there might be some interesting properties of the biochar developing that might be worth being analyzed, also maybe by you. As I said, combined pyrolysis and gasification process, they are producing electrical and thermal energy. And biochar is, well, was considered a side product, but it's becoming more and more important. The top right plant is a new Pyrac plant, P1500, that produces heat and thermal energy and biochar, very high quality. And the bottom right picture shows an electric pyrolysis of ATIA that functions with an inductive heated screw. And with this, it is possible to use all three phases of the pyrolysis: the gas, the oil, and the solid phase, the biochar. So these provide entire systems that can comply to EU and national regulations. Those regulations can be, well, they have to be considered, and they can be a bit tricky sometimes, because it starts, pyrolysis plants are not necessarily known to our bureaucracy. So it starts with the question, what is this type of plant? Is it a waste treatment facility? Is it a furnace? Is it an energy production plant? So depending on this definition of what your pyrolysis plant is, the producer also adheres to different regulations. Yeah, sometimes it's preferable, for example, not to be a waste treatment facility in Germany, but rather something else, because the goal is actually biochar production. So the input material and the production plant have an impact on the product, the biochar, and its marketability. So the question is, can waste, if the input material is classified waste and has a number, cease to be waste, and under which circumstances is this the case? What is necessary to undergo this process? I will not elaborate too much on this, but I think you see the difficulties or the topics that are occurring. So that might have been one of the reasons why the development of the pyrolysis or the biochar production has been a bit slower than expected maybe 10 years ago. But we're talking about technologically mature systems here, and such a system is one that guarantees stable parameters, continuously low emissions. It adheres to safety regulations and provides a constant high quality of product. In our case, first and foremost, biochar. So the product quality of biochar is of utmost importance for the use. And now we're at refinement and trading. Well, of course, there are also interconnections, but I'll put this here. There are a lot of biochar producers, biochar refiners, manufacturers of different types of product. Here we have some agronomic uses or products. Some of them are pure biochar, some of them are mixed, blended with other materials. And the first thing that's important here with regards to regulations is REACH. REACH is, well, we call it the birth certificate of a substance, and that counts for basically all the biochar that is produced if it should be traded. An exception is if it's used under the GMP plus as a feed additive. It has to be produced and used as that, then it's REACH exempted, but then there are other regulations that count. So on top of that, there are national regulations with regards to the quality and the application of the biochar. For example, regulations for soil amendments, fertilizing products, also feed additives. And And then one of the most important ones now is the regulation 2019 1009, which regulates the use of biochar as a fertilizing product that will enter into force July next year. There's still a comment we can cover on that. I've also posted some information on that. So we're not only talking about agriculture, and that's a very important point. It started with this, and agriculture is certainly now rather well known, but the big market for biochar might be somewhere else. This is just one example. They are making biochar-based thermoplastics, and if you're considering such an industry, industrial process, of course you need a standardized biochar with a constant level of quality and parameters. In this case, it's made of air, and they're making a thermoplastic that's being produced, that's producing furniture, lenses, even wall tiles, and several different things. And they need a certification, or they need at least quality standards. And how do you achieve them? The best way would be a certification system, which exists. It's called EBC, and the EBC certification defines the qualities of this product. It categorizes biochar into different application classes, which are called agro-organic, feed, and material. Those classes are not, it's not limited to 4. They are still open, and with new developments and new uses of biochar, more classes will be created. So for example, if the use in concrete is becoming more interesting, industry and science together will, I hope you can still hear me. If not, just tell me, because it says I have an unstable connection, can create a new class together with the EBC. So different classes are defined. There is a feedstock list of possible input materials for pyrolysis, and the properties of the material of the biochar are defined. So it's C content, you see it, HC, OC, nutrient content, which is important not only for agriculture, but also for the properties of the substance for industrial uses, heavy metals, pH, bulk density, water content, pore size, pHs, and several more. EBC also has a zinc certificate. It certifies the actual carbon zinc properties of the biochar. And that can be elaborated on, but not in the limited time I have here. So with this, we're coming to our key activities as the industry association. We're working towards good regulations and an enabling environment for the biochar and pyrolysis industry. So we're working on policy, as you have seen. That is an important point, and we're in different groups in the fertilizing products expert group, for example. We are an observer. We're in different groups. We're active on the European level, but also on national levels, just ourselves and also with our partners. We are providing market intelligence and continuously updating them. We're communicating. Communication this year has been a major thing. A nice basis we have created is a white paper on the carbon sink potential of biochar and the possibility of the potential to mitigate the effects on climate change. And now we're communicating through different stakeholders on different levels with regards to that and other topics of biochar where we can be helpful. And we're working on industry standards, also working on the EBC and with EBC and on other standards, because we are a clean tech, and we have to stay that. So one thing is we have to represent what we are and stay a clean technology. On the other hand, we need industry standards, as I said, because we need clearly defined products, because it's not just biochar, it's many different types of biochars. So therewith, we're trying to eliminate market barriers and demonstrating our commitment to clean technology, as we want to foster the long-term success of pyrolysis and biochar and make a meaningful contribution to mitigating climate change. This last subject is become one of our most important arguments. I'll start with because I like this short video on the temperature anomalies, since the measurements of temperature that show a rather clear image. While several decades ago, it was not so evident, even though we had the scientific knowledge that we are in a changing climate and that we have provoked it. But during the last years, and it has become absolutely clear where we're standing and that we have to act, that we have no option but to act. And I'm stressing on this, not because I think it's not only because I personally think it's an important issue, but also because it's just why people are now looking for biochar solutions. And why are they doing that? It's exactly for this. We need carbon sinks. We need to exit out of fossil fuels as quick as possible. That's out of discussion. But this will not be enough to achieve the goals we have set in Paris, for example, or to a bit drastically said, a bit more drastically, but I think realistically, to continue living in a world that's somehow like what we know. So we need those carbon sinks, and we need a lot of them. I will not elaborate too much on this because of the lack of time. So we need, carbon sinks. We have 6 possibilities that are actually discussed at the moment, the so-called negative emission technologies. And we have, we are focusing especially on the upper 3 of them, which are the nature-based solutions. They are afforestation, reforestation, biochar, and the buildup of soil organic matter. Those 3 have a particularity that they are available right now, they're scalable, and they offer co-benefits. And biochar, interestingly, has synergies with most of them. So not only with the nature-based ones, but also with others. But yeah, then the most important point here is that it's not about competition, which is the better way of sequestrating carbon, but we need them all, and we need to see that we get the most out of all of them. So we are convinced about biochar, and we're happy that biochar also has synergies with others that helps to even increase the impact of other nets through the use or inclusion of biochar or pyrolysis. So our value proposition, actually a bit quicker than I thought. Our value proposition is that we can provide climate neutral or CO2 neutral energy, and we can also produce negative emissions. This is the main part, and with those negative emissions, we haven't even talked about all the positive effects of biochar use, which have been in part explained in the presentation before that. So here are some of the fields biochar can be used in. Interestingly, in last year, 2019, we thought this is a quite actual image, and it's a bit of state of the art. But I think now we certainly have to update this This will be one of my tasks during the next weeks, because after so many recent developments and publications, things have clearly changed. Also from our side, we have biochar asphalt in the EU. I'll come to that now. The concrete and cement producers, they will follow. We already have some demands. Steel industry is way beyond trials, and they need large quantities of biochar to produce the first batches. And in other types of uses, they are quite commonly known. Cosmetics, for example, in most of the stores, you can find different types of cosmetics that are quite popular. Sanitation use, sludge treatment. In medicine, there might be a room for improvement. High tech, we've just heard. Construction is quite well covered. See very interesting developments in the near future. This is to close. It's an example where we have pioneered the use of biochar in the building sector in Europe, with just adding biochar to replace some of the filler in asphalt. And with this, we have achieved a climate positive production and implementation of asphalt, with only 2% biochar replacing 2% of the filler. So the mix has slightly changed. The quality of the asphalt is apparently has not changed. So it's just a carbon sequestration method with biochar that is maybe, for example, not suitable as animal feed. It would be a very good way to sequester large amounts of carbon, because actually a lot of asphalt is used. We're talking about the asphalt and not about the roads, and we're not talking about faults in our transportation system, or if we have to change from individual vehicles to public transport. So it's just about the asphalt layer. But that's a try that initiated a lot of demand for climate positive products, because it shows that it's possible with just minor changes to actually change the quality of your product. And at the moment, many companies are interested in a product that is not doing damage to the climate. So this is how we have created quite some dynamic. Yeah. Now, last one about the market demand. With the growing knowledge base, and we have developed about 80% of the scientific knowledge during the last 5 years, and with a growing communication through all of you. I mean, that's what the us is supposed to mean. I'm very happy to see so much going on and so much good communication on different levels, and those best practices, and the future uses of biochar. I think we have a prosperous future before us. So biochar is becoming increasingly important. Thank you. This is so far my presentation. We have 5 more minutes for discussion, maybe a little bit more, and I'm happy to hear your questions. Those you can scan those images to follow to our homepage or LinkedIn page.
Thank you very much, Harald. Nice presentation, and very interesting to hear about the European Biochar Industry Consortium. You got a couple of questions in the chat. The first one from Przemysław Matsiaka. I would like to ask how the new Green Deal, the EC directive, tackle the biochar application in agriculture. Do you have any information in that regard?
How the new regulation tackles the use of biochar?
Yes, if there's any mentioning, I guess, in there.
Oh yes, of course. There is a whole chapter on pyrolysis and gasification derived materials, and it is quite comprehensive. It's from a broad base of input materials, and it's basically a gate opener for high quality biochar with low PAH levels and low contaminant levels for EU agriculture. It will enter into force July next year. I can share the document. I think we have to see where we best share it. I did share it on our LinkedIn page. I mean, you, but let's say I'll also put it on the homepage. I was going to do that anyways.
So I guess it's a hint for people to join you on LinkedIn. So the next question was how I can become a member of EBI. I guess that's hard for a scientist like Przemysław.
Well, for scientists, just talk to me. We have to figure something out. We're actually set up in our creation for industrial members, including the member fees, but also I would say we need to work in close cooperation with research institutions. So we're highly interested in the cooperation. Just contact us. I'll just write my email in the chat.
Are there any plans or any strategies from the EBI how to exchange ideas with research institutes yet, or any formal?
Yes, we're already working together with certain research institutions. We'll be having a call with Politecnico, also because we've heard of each other, and we've been in contact before, and this is the future of our work, I would say. I mean, research is the foundation of our work. We need to know what is possible, and then we can bring people together with the respective industrial actors. And from the other side, we have a growing demand. So I'm in lots of talks with actors from industry, from different companies, trying not only to buy carbon credits, but also to really improve their products and have something with a better carbon footprint. And of course, that it's the direct, it's what's possible in which case, because we cannot just know. We need the solid foundation for that.
So then there was a question from Core Organics. Biochar can be generated by many different substances. What strides have we done to research and study the best materials to use? I have many suggestions and I can't be working diligently on producing them.
Well, what we are aiming at is to use residual materials. It depends on the way you tackle the issue. But for us as EBI, it is the first question is, what resources do we have available? So because before we are planting miscanthus, for example, we will check what is already available and not necessarily being used in a preserving way. So we would use those first, and then analyze. We will use the biochar that's resulting in a way that's appropriate. And we have certainly a lot of waste streams where we could use some improvements that will be possible through pyrolysis. And then, of course, if you need specialized materials, then you need to look at possible different feedstocks and produce specialized qualities of biochar for your specific needs. So there are different ways to tackle that. But the first thing generally is really to use existing material flows, existing waste streams to produce biochar products.
Thank you. And then there was a question from Jorge about when you talk about biochar, does it exclusively relate to the solid residue from pyrolysis, or would it include also HTC chars, for example?
We are talking about pyrolysis. At the moment, it depends. I wouldn't absolutely limit it to it. At the beginning, it was said it's pyrolysis. Now it's pyrolysis and certain gasification plants also, because they're just able to produce a product that is of a quality that is comparable. It depends also if you want to consider the sink value of a biochar. But where do you start? Do you start with torrefaction? For sink, it might not be make a sense, even though if it wouldn't be used in an energetic way for energy production. So at the moment we are saying pyrolysis and gasification, but it's not a absolutely restricted system.
And I guess that will evolve with time too. I'm pretty sure you would exclude charcoal producers, traditional one, like barbecue charcoals.
Well, it's also, I think it's necessary to produce charcoal in a sustainable way. But we're talking about the material use of carbonaceous products. So if it's used to be burned to produce energy, it's not biochar in our sense. This is why the limits, why the numbers are quite small. We are considering biochars that are used in a material way.
So then there was a question about the asphalt layers from Elias RC. So they wear with time. What happens to the biochar in that case? Was there research before about long-term effects, or?
No, it's a very recent study, so we do not have any data on that. They wear with time, but they deform, I would say. I don't know how much of these 6 centimeters or 12 is worn off and how much biochar is lost. But this is the calculation that will not be too complex, because the wearing off of asphalt and on different types of roads. Where it's been implemented, it's a 30 kilometer per hour road, so it's not high speed. I think the wearing off is not so much of an issue, but it depends what you want. Why you pose this question? Is it because of the carbon sink value? Then you could deduct a little bit. On the other hand, you would have the advantage that if biochar is included in the structure of asphalt, it will not degrade. If you use it for agronomy, you have a small fraction of a percentage per year where it might degrade, depending also on the CNO ratios. Yeah, so it's a long-term effect, I think.
Then we had another question from Sandra. What do you think about biochar in medicine? For example, removal of certain antibiotics. What resources do we have to study the structure of biochar and refined elemental forms of biochar? I guess a more general question about biochar applications in wastewater filtration or something similar like that.
I think, yeah, because in medicine itself, you might probably not want to remove the antibiotics. I don't know, but as a ladder, an added step of wastewater treatment, I think there it's highly interesting, because you can regain nutrients that would otherwise be lost. You can have extreme, and I think the speakers before, they have a lot more information on that, so they could certainly answer this better. I've read Mattia Bartoli's paper recently on non-agronomic uses, and there he talks about coating different treatments of biochar, through which you can filter also heavy metals out of wastewater streams. There's an extreme potential that certainly has to be considered.
And we got a follow-up question from Przemysław. Is there a difference between charcoal and biochar in the certification? So can a charcoal producer certify its charcoal as a biochar?
Yeah, so there are charcoal producers that are now interested in biochar production. It also always depends on the prices. It's a very interesting development, and there are certified known charcoal producers that are now also switching to biochar production. It depends on the facility. If your facility is capable of producing high quality biochar, of course this is possible.
Would you, a follow-up question for myself, would you think that could lead to some issues, let's say, if we get biochar that is sold as a carbon negative briquette for barbecues?
Oh, no, this is not possible, at least not with EBC certification. If somebody else develops a certificate that makes that possible, yes, but we will certainly not be behind that.
Okay.
So for example, the EBC Sync certification, it really looks at the use of an appropriate use of this biochar, so an actual sink is created. It's quite rigorous.
Yeah. And then Michael Riedesecker asked, can you imagine when and if the public sector will start with call for bids with CO2 neutral building materials?
I'm hoping this will happen soon. I think we need a bit of work before. We need some pioneers that try it out and give us a proof of concept. And as we see it with the asphalt issue, for example, it is creating a lot of interest once something is really implemented and working. So I think we need those practical examples, and we need some pioneer work of actors that really want to make a difference. And I think if that is done, and if the possibility exists to create a product that either emits a lot of carbon dioxide equivalents, or sequesters carbon, I think the pressure just by what is occurring right now in nature and how we're changing it should lead us to the point where BITs also request that. But I think we need the foundation for that.